Hello, friends. Good evening, and welcome to my YouTube channel with the name Researcher Yugal. This is my new YouTube channel because the content was mixed up in the first YouTube channel, and I have already posted video about this. So at present, I'm continuing the series of discussion on electronic devices and circuits, and I have already made 7 videos. So in this continuation, this is the eighth video that you can understand. The previous videos are in the playlist Electronic Devices and Circuit Theory. This is from the book called Boylsted, and it is a very famous book for the student of electronics and those who are the student or the technology people or the technology enthusiast or the people who are working in the field of electronics. So electronics is something which is the theory of electron and how does the current flow in the case of the semiconductor and thereafter things follows up in the case of the applied electronics, basic electronics, or the fundamental electronics. So let's continue our discussion. We were discussing, let me share my screen with you. So now my screen is shared and let me share the content. So uh, we were discussing the Zener diode, resistance, capacitance, clipper, clamper, rectifier, and these circuits in the previous videos. But now we are discussing some important circuit that is known as the voltage multiplier circuit. As the name suggests, the voltage multiplier is a concept where the input voltage get multiplied and you get the amplified or the multiplied output. For example, if you are giving 2 volt and you need to double the output, so it will be multiplied by 2, so the output will be 4 volt. You are giving input as 2 volt and output you are getting 4 volt. So it is multiplied 2 times. So that circuit will be known as a doubler, double. So it is called doubler circuit. So it is called, sometimes we have single way circuits, single multiplier, double multiplier, triple multiplier is called tripler. And if you are multiplying 4 times, then it is called quadruple multiplier. So likewise, you have two, you can see in this here, it is mentioned. I'm highlighting this as a 2, 3, or 4 or more times multiplier circuit are available. So as you can see, first circuit that we are discussing here is a voltage doubler. It is written in the blue color, and you can see the figure 2.123, and this is the theory behind this, and this is the analysis. And you can see the output is as the output voltage will be taken out across the capacitor C2, and the voltage is equals to VC2 is equals to twice of VM. VM is the maximum voltage. So let me understood the operation of the circuit, and you can do the analysis by yourself. But first, try to listen what I'm trying to say. If you were able to understand what I'm trying to say, then you can easily understood the operation of the circuit. Now, in the operation of the circuit, there is a transformer. So there is a cycle, plus cycle, or negative cycle. So let's consider the positive cycle. So positive means plus and negative means minus. So plus, this capacitor C1 get charged to voltage called VM. Okay, it is fine. And those who are a student of electronics can easily understand, and the people who are studying electronics can understand how does the capacitor get charged. Capacitor charges slowly but discharges fast. So, sorry, it charges fast and discharges slow. The graph is like this and slow. Graph is like this. So you can understand what I'm trying to say. Now there is a D1 diode. In the positive half cycle, the diode will be forward biased and the capacitor get charged. Now in the reverse bias, the diode will be off and it will be open circuit, and you will be having VM and plus VM from the capacitor, and plus minus negative will be here in the negative half cycle and plus will be here in the positive in the negative half cycle. So these VM will act as a voltage, and this transfer voltage across the transformer will also act as a voltage, and it will be reverse biased. So this D2 will be on because this will be this will be forward biased due to the negative half cycle. So this is forward bias and this is short circuit. And this capacitor C2 now will charge up to the capacity of the 2 VM. Why? Because there is a voltage from the transformer and also there is a voltage from the capacitor, which is VM and VM. VM from transformer and VM from capacitance. So plus minus VM will be will give you 2 VM across the capacitance, and hence the output will be 2 VM. But it is negative polarity, and you can change the polarity and you will get the output as 2 VM in the output. So what is the output voltage? Output voltage is the VC2 and you're getting as 2 VM. VM is the maximum input voltage. So likewise, this circuit is working as a voltage doubler. So because there is it is doubling the half wave. So that's why it is called half wave voltage doubler. So you can see the operation in the figure A and the figure B of figure 2.124. It is multiplying the positive half cycle and negative half cycle. If you change the polarity of the diode, then it will work in the opposite directions, opposite polarity. So there is a positive half cycle in the figure A and negative half cycle in the figure B. And this thing I already told you in the just I told you, and you can play and pause and you can repeat the statement what I've tried to say in front of you. So this is how a voltage doubler begins. Now, before continuing, before scrolling the next page of the book, I would like to give you some intuition. Intuition means, see, you have used two capacitor to double the circuit and two diode to double the circuit. So just consider it as one capacitor and one diode. One diode, one capacitor. One diode, one capacitor. So if you will use three diode and three capacitor, it will act as a voltage tripler. It is giving some intuition, and I have already known this. And I will show you the circuit as well. Let me show you in front of you. So, like if you want to complete the full wave of the doubler, so you can arrange the circuit like this, and the operation of the circuit remains the same. Just arrange the capacitance like this, and the operation will be the same. And you can understand the operation from these two circuits, figure A and figure B. And it is very intuitive that you rearrange the circuit, then you can get the voltage doubler for the both the cycle, the positive cycle and the negative half cycle. So this is not a big task. It is not a big challenge. Now, what I was saying that if you want to design a voltage tripler or voltage quadrupler, so just see the number of diodes in the circuit. See, from this point A to this point B, you are acting as a tripler, 3 VM. Why? Because one capacitor, one diode, second capacitor, second diode, third capacitor, third diode. They are arranging in a RC format, and you can see the across the voltage across the D3, you will be getting 3 VC, 3 VM. So hence this circuit is acting as a voltage tripler. But suppose if you want to design a voltage quadrupler, then you need to add one more capacitor and one more diode. So the number of the diodes in the voltage quadrupler will be D1, D2, D3, and D4. So there will be four diodes, and the number of capacitance C1, C2, C3, C4. So there will be four capacitor. Likewise, if you want to multiply the with n number of times, then you need n capacitor and n diode. Likewise, the circuit is working. So what I've said you intuitively is you can see here in this particular circuit. See, I have already read this book, and I've already not thoroughly, but I have tried to read it thoroughly. So I have the intuition. But if you have not seen the circuit, then intuitively you can design these circuits by the basic understanding of the voltage doubler circuit. And if you think some more prospectively from the research point of view, the capacitor charge in the clamper also there was the capacitor. That's why it is hanging the wave from one voltage level to other level. Now it is hanging the voltage level from V to 2V. So you need one capacitor and one diode. That's why sorry, two capacitor and two diode. Likewise, it is performing as a clamper only, but because the number of capacitance increasing, so it is charging many fold times, two-fold, three-fold, or four-fold. That's why it is working as a voltage multiplier. So this is a simple understanding that I'm trying to say. Now come to the practical applications of the diode. I have already told you in various sequences in this video that it worked as a rectifier. Rectifier are of two types, matlab half wave and full wave. And now you can see these are the practical circuits of these are the battery chargers. How it does it look like? And battery charger does have a rectifier because the normal supply you get in household is 50 hertz and 220 volt. It is a AC supply. And if you want to charge the battery of your mobile phone or any other electronic appliances which contains a battery, so you need a charger. So the charger converts the AC to DC, then you get it charged. So this is the practical application. Other practical application, we discussed the Zener diode, we discussed the LED, and we discussed other circuits as well. So these are the things that are related in the applications of the diode. So I think this was the last topic in this particular second chapter. Let me scroll it down for you so that see polarity insurance. You already know that the diode works in two polarity. One is forward bias, and the other is reverse bias. So if you want to use a circuit as a switch, then you need to have a diode because the switching applications are much better with the help of the diode because it works in two mode, forward bias and reverse bias. And if you want to make it no bias, then it is worked as a no bias. So these are the things you can understand from this particular diagram that there is a battery called 12-volt battery, then there is a diode D1, and there is a diode D2 in opposite polarity, and there is a battery called 9 volt. So likewise, if you want to shift the voltage from 12 to 9 or 9 to 12 or the difference of the 12 and 9, then you can switch with the D1 and D2. That's why you will get you from this combination, you will get 12 plus 9, 21, 12 minus 9, 3. So likewise, you get 3 volt and the 21, depending on the switching of the diodes. So I think, and this displays we have already discussed using the LED. Like suppose if you want to design an exit display, EXIT. So these diodes are arranged in the form of E. These diodes are arranged in the form of X. This is I and this is T. And if you apply the voltage across them, then there is a diode. So all the forward wise, these are in forwardizing mode. These will be on and the LED will be working and it will be blown off and you will get the message at exit. So you have seen the various cinema halls and other places where the exit sign is there in the railway station, metro station, bus stand and everything, and even in the cinema halls. So you can see the sign of exit. So these are glown with the help of the LED. Likewise, you can design n number of, like if you see the buses today, they have the LED display. So any message can be displayed over the LED with the programmable LEDs, and you will get the output depending upon your needs. So we have the regulator. Regulator can be designed with the help of the Zener diode, named after the scientist Zener, Z1 and Z2, Z1 and Z2. And so this was the thing. So I think this was the summary of the second chapter, and you can read it out. And somebody, I have already just told you the number of applications and everything. So you the computer analysis you can do with the ORCAD Capture CIS demo. It is a software that you can download and you can do the analysis. The name of the software is ORCAD 16.3, which was established for the project purpose. So that's it. This is the interface of the software, ORCAD Capture CIS Demo Edition. You can download this software, and there is some application of Cadence also. So maybe this is related to the Cadence also. So you can download this particular software and do the analysis of the various applications of the diode because, and you can work on LT Spice as well. And there is a software called Tina TI as well. I have one video related to the Tina TI. You can search in the playlist as well. So these are the things that can be done with this diodes and multisim. Multisim is also one of the software given by Cadence or Cadence multisim, multi simulation you can do. So there are some problems as well on the based on the this application of the diode 2.2. Then you have the graph understanding 3, 4. 5, 6. So there are n number of problems that you can solve. You can see this one more circuit, silicon, gallium arsenide. So the drop of silicon is zero point 0.7, drop of gallium arsenide, you can see from the table, silicon drop is 0.7, zero point 0.7, zero point 0.7. So you can do some circuits analysis, circuit problem solving circuits. You can do this to memorize or conceptualize the concept of the circuit diode application discussed in this chapter 2. So I think that's it for this particular video. Now we will meet in the second part of the video with our discussion on bipolar junction transistor, which is the third chapter of this particular book that is known as the Wall Street. So I think that's it for today's video. Let me stop this screen share, and we will meet you in the next video with a discussion on bipolar junction transistor. Bipolar junction transistor are also very important, so you need to study about them. We will meet in the next video with the discussion on BJT, that is the bipolar junction transistor. So thanks for watching. Have a nice time.